Yeah, I forgot to bring a picture of our two cats, but and I forgot that I said that before. But it's true. I really like and love cats, and cats understand me for some reason. Dogs is another story. Yes, what I would like to talk about with you today is circular building installations and a bit from a systems approach. I used to work as a consultant the last 30 years. And then, of course, it's always about designing systems with indoor climate, energy, circularity, etc. in mind. And also now when I teach to my students at the Faculty of Architecture at TU Delft, it's also about system design. So I know a lot of you are into component manufacturing. So some of the examples I give, well, it's because of this system approach. And I think we need both. So we need people that think about components and how to make them more environmentally sound, but also people that know how to design buildings in such a way that the environmental impact is limited, at least further than what we do nowadays. In my days as consultant, I recently stopped doing that. So kind of since this month, I'm only connected to the university. But in my 30 years of consultancy, what I noticed that if you talk about HVAC systems and indoor climate technologies, when you do a real project, there's a lot of talk about costs, investment cost, operational cost, if you're lucky. There's a lot of talk about energy performance requirements, net zero energy building requirements, etc. And there's a lot of talk about comfort and indoor climate and health, productivity effects, etc. Which is good, I think, but now we are in a phase where we need to start thinking about how do we create these indoor climates and how do we limit this energy use with what kind of materials? What is the environmental, the hidden environmental impact of those materials, the heat pumps, the ventilation ducts, the controls, HVAC controls, etc., etc. So that's basically the phase we are in. And this, of course, explains a lot of the latest development in related to regulations. And also changes in demands from clients, building clients. Yeah. This is a project I did quite a while ago when I was still working in consultancy, and I've done other projects like this. So this is not a standard product. So once every 50 products or something, you run into something like this. This is it's not in the Netherlands. It's somewhere around the Mediterranean Sea. I'm not going to say in what country, but this was a typical example where they generated kind of a standard office building. It was hired by a kind of quite demanding client. And then after 2 years, they found out the ventilation ducts were too small, the system was too leaky, it was too noisy, etc. So they decided after 3 years to take out all the ventilation ducts, a lot of the dampers, controls, etc. And to kind of reinstall it. So they reused the air handling unit, again, after 3 years. And this still happens. Sometimes it happens after 8 or 10 years, and this is not what we want. We don't want this take, make, waste approach, but of course we want people to be a bit more considerable about the materials that we use, and I think this can be done. Yeah, when I talk to, in the Netherlands, with an average installer about circularity, I often get this reaction, like, oh, we are already very circular, and we're doing a very good job. No need for further actions. I don't understand all these regulations from Europe because we use recycled material, have ventilation ducts, maybe 30 or 40% recycled steel, zinc, etc. We use heat recovery, so we're already super circular when it comes to energy. That's one big circle because we reuse 60, 70, 80% of the heat. We have developed fans that are more and more energy efficient, so everything is already quite circular. I don't know what you talk about, and yeah, that's it's always a good start for a conversation. Let me put it that way. Of course, the awareness is slowly changing. And this is partly due to some recent studies that we did in the Netherlands. This is one, this is about renovating office buildings. And there was a company, Metabolic, who did some calculations looking at all kinds of environmental impact, also looking at water pollution, for example, or air pollution effects. And then they looked at the total standard renovation in an office environment. So you change the office again to a more modern office building. What is the hidden environmental impact? And they found that the combination of electrical and mechanical systems, the environmental impact related to those two aspects is about 25%, a little bit more. I've seen other studies where it's even more in a renovation situation. So I show this picture a lot when I talk to my colleagues from architecture, for example, at the faculty, because they think in terms of weight. So they think that all these ducts and heat pumps and even electrical appliances are not important because they're relatively light. But then, of course, I show them figures like this. And again, there are other studies that show, especially in a renovation concept, that this 25% can go up to 40%, something like it. So it's relevant that we think about this. Another thing that, of course, we have to keep in mind, if you, like an average building, maybe the structure will be there for 100 or 150 years. Maybe after 50 or 60 years, they will change the facade. But the HVAC components, maybe already after 20 or 25 years, that's what this figure says, the components are changed, or at least the majority of the components are changed. So within the 150 years that the structure itself is there, you already have 5 times, something like 5 times a mitigation moment where a lot of the metals that were in those installations are taken out. So there's a lot of movement there, and of course that's an extra reason, I think, to really dive into this question, how can we make building services more circular? Well, this is something, where is Walid here? He knows what I'm talking about here. I know he had some very bad nights. Where are you sitting, Walid? And I think he had to leave for somewhere else, from the Dutch association related to Eurovent. So when we first started the Dutch environmental calculation system, there was some values put in the system. I think it was people that maybe didn't have an HVAC background that kind of calculated what the environmental impact of an average heat pump is. And then after a while, they tried to assess if these assumptions were right. Then some HVAC people were involved. And then the conclusion was the actual environmental impact was more than a factor of 10 higher than they thought beforehand, because they forgot about the refrigerants that leak, that you have to exchange, etc. And they forgot about the electronics that you need to control, for example, for temperature control. To all of us here, that's very obvious that you have to think about that, but it also tells a little bit about the kind of first that you meet when you look into calculation tools, for example, for environmental impact. And of course, in retrospective, it would have been nice if the HVAC people, maybe including me, would have been a bit more proactive and already during the first round would have been at the table. Anyhow, so this ended up in the newspaper, and then people were saying, like, if you want to do environmental buildings, don't do any HVAC equipment anymore. Anyhow, interesting discussion again. One specific reason why I got interested with my chair at the university into this subject is especially this, circular critical raw materials. Who knows this report here that I showed, a study on the critical raw materials for the EU? Can I see some hands? Yeah, you all read it. It's not that many people, I think maybe 10%. I think maybe next year when I ask the same question, if I'm here again, then it should be 90% at least, because this is a very important report, I think, and it really tells us about not what the politicians want with a subject, but what's something that is really possibly disrupting the European economy in the near future. Well, that's all I'm going to say about it right now. Of course, in the report, it points out, I think it's around 47 materials now already, strategic materials, critical materials for example, for the energy transition. And it's basically about materials that are mainly produced outside Europe and that make us very dependent upon other countries or countries with refinery industries. There's an opportunity there for a disruption of the market, and we have to come up with a plan. And basically in the report they say we have to start rethinking if we should do more mining in Europe. We have to increase recycling, and there's a lot of more ideas in there. I think it's very important. In that context, I have some colleagues, David Peck, for example, at the university, and also people from other universities in the Netherlands, and they wrote this white paper together. It looks like a book, but you can just download it. And it basically it talks about critical metals, materials, but also the green energy transition and geopolitics. And the title speaks for itself, a complex mix. And they basically say, like, we cannot have an energy transition without a good plan related to especially critical metals, critical materials. And again, so building service systems are quite critical material intensive. So this is a must read also for all of you, maybe. So check it out if you want. Already other people talked about this. So there's all kinds of movements in Brussels related to environmental impact of materials, and not just about phones and clothing and whatever, but also related to our industry. And this is, I just wanted to point out what it says in that document. Quite a few of you probably know it, but especially in Article 16, it basically says it's not just about embodied carbon and a whole life carbon approach. What the EU plans to move towards is an approach where we look at products and also systems and the durability, reliability, repairability, upgradability, recyclability, options for refurbishment, designing for easy maintenance, and what does it say? Oh yeah, here the recovery of critical raw materials. So that's something that also they expect us, all the people of Europe, including industry, to dive into. And this is easier said than done. It's already complex enough if you look at just embodied carbon, for example. But it's quite ambitious. I think it's a good idea to look at this. You can discuss about how fast we should do this and what's practically possible. But anyhow. When I talk to my colleagues at the Faculty of Architects and we talk about building service systems and metals and critical materials, they often come back with me, can't we just make buildings without any installations? And then they refer to this example from Austria. This is actually a building that, at least they say, don't really have active cooling or active heating systems. But for example, they use natural ventilation, very advanced with servo motors, and there's all kinds of controls in there for temperature. So there's a lot of building service components in it. It's just different than the standard approach. But there's a lot of thinking, especially amongst architects, that we should move towards doing no installations at all. I don't think it's possible. You don't want to be operated in a hospital without HVAC equipment, for example, or go to a nightclub where they don't have it, or a large office building. But anyhow, so think about this one. And I think it's a good idea to ask sometimes the question, do we really need these very intensive, installation-intensive buildings? But no installation is definitely not an option. Well, I would like to end. This is some Dutch market initiatives. So one is about circulation pumps for heating systems, and there's already like a company that is cooperating with 7 producers of these pumps, and they collect it for them and they sort them out and help them to bring them back to the factory and to remanufacture them or to reuse them when possible. Other examples are related to, for example, reconditioning of air handling units, which help to extend lifespan. So there's a lot of initiatives going on, probably in your countries too. This is a project I really like. It's from the Dutch government. We recently started with a PhD study. Somebody who actually works half of the week at the Dutch Governmental Building Association. And this is a project where they try to reuse all kinds of components from a donor building, including air handling units, but also climate ceilings, for example. These were 20-year-old, and then they kind of reconditioned them, repainted them, connected them, and it was a really good exercise in trying to do that. I'm not saying that this is cheaper than to do everything new, but it was a good experiment, I think. This is just an example of the kind of project we do at our university. So here I asked one of my students, okay, let's assume we want to do a ventilation duct in a circular way, and we want to do then like non-metal solutions. And looked at all kinds of solutions. Actually, what we normally do with zinc and steel is actually not the best solution, I think. That's one thing we found out. But one thing, actually the right corner, he came up with is to use bioplastics in combination with Tetra Pak, which is a material that you all know from apple juice cartons, for example. And so it's a very interesting project. I don't think we have now the solution for this, but that is the kind of project we try to do with our students. This is another project where it was kind of about cooling, like small-scale offices, schools, dwellings, older dwellings, and then we looked at not solving it with active cooling systems, but with doing more with air speed, with ceiling fans, and this worked actually pretty well. So if you have questions about that, ask me maybe in the break. And yeah, and this. So there's all kinds of projects going on in the Netherlands. For example, this one instigated by RVO, which is from the Dutch government, and it's yeah, quite an interesting project that focuses specifically on HVAC systems. It's not just a poor technical challenge. This is a very good article. It describes that, yes, to think about circularity in terms of redesigning HVAC components or maybe reusing them, that's one thing. But you also have to talk about a different way of making contracts. You have to talk about logistics, where to store, for example, your components from a donor building, etc., etc. So this is a really interesting paper that explains to you how complex it is, the subject we talk about. I'm nearly finished, Francesco. I see I'm just past 0. A few personal remarks. I think this is the time to start thinking about resource efficiency and to look beyond just energy efficiency. So it's not a myth we talk about here. It's a very complex subject, but it's one that also comes with a lot of challenges and opportunities. I do especially see opportunities for early adopters, for example, like manufacturers that dive on this subject and at least make some of their products more circular and less impactful on the environment. And my last slide is a reference to Goethe, who said that everything is hard before it is easy. Well, this is very true. I think 4 or 5 years from now, we will look at us and like, oh, well, now it's kind of becoming easy and we have tools to really calculate environmental impact. Right now, it looks like a big challenge. I agree with you, and let's try to dive into the challenge together. Thank you very much.